Hello again, class. I want to do one more example for you. So again, we're going to solve by completing the square here. At the end of my last video, we talked a little bit about why you need to know how to solve by completing the square. And this is a great example of that. Let's go ahead and take a look at this problem. So we have x squared, I'm going to start over here. X squared minus 10x plus 23. And that's equal to 0. Okay? And I'm sure a lot of you, your favorite way to solve at this point would be to solve by factoring. So let's solve by factoring, right? If you were in my class, I'd say, somebody tell me factors of 23 that add to negative 10. And I would sit here and I'd wait, and I'd sit here and I'd wait, and none of you would come up with anything because there aren't any. All right? We cannot find factors of 23 that add to negative 10. So we're stuck, right? What do? This is why we need to know different strategies. Now, we are left with two options here. First, we can solve by completing the square, which is what we are going to do. We could also solve using the quadratic formula, but we haven't learned that yet, so we'll hold off. Let's solve by completing the square. Here's what we're going to do. I'm going to start by getting this 23 out of the way. Let's just get it out of the way. I'm going to subtract it from both sides, leaving me with just x squared minus 10x is equal to negative 23. You may be wondering to yourself, why did you leave that space there, Mr. Lynch? And the reason I did is, we need space to complete the square. So that space right there, we saved to complete the square. So, x squared minus 10x. To complete the square, I'm going to add some mystery blue number. And of course, if I add that mystery blue number to the left side, I better add that mystery blue number to the right side. Let's go ahead and figure out what that number should be. I recommend you pause the video right now and try it on your own and see if you got it right. Pause. All right, I'm going to do it though, because you can just pause yours. So, we take our middle coefficient, negative 10. We're going to divide that by 2, and we are going to square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So what that tells me is 25 completes the square. Great. Let's go ahead and rewrite this. So now we have x squared minus 10x plus 25, which is a perfect square trinomial. Mr. Lynch, how do you know it's a perfect square trinomial? Well, you could test it or you could trust yourself because we just created it to be a perfect square trinomial. So we already know it's one. Assuming you did it right, of course. And that's equal to negative 23 plus 25, which is just 2. Now the whole point of writing that perfect square trinomial is so we can easily factor. Again, to factor a perfect square trinomial, we make one set of parentheses. We take the square root of the first term, the square root of x squared is x. We take the square root of the last term, the square root of 25 is 5. And then we steal this sign right here. So this will actually be a minus. So x minus 5 squared. And next we're going to begin the process of solving. So I'm going to take the square root of both sides. So here's what I'm left with. The square root of x minus 5 squared is just simply x minus 5. The square root of 2, you can use a decimal if you'd like. I'm just going to leave it as the square root of 2 for now. But don't forget you need to write it as positive or negative square root of 2. Little fun fact. We talked about the perfect squares. 1, 4, 9, 16, 25, 36, 49, 60, 41, 100, so on and so forth. The square root of any perfect square is an integer. The square root of any non-perfect square is actually an irrational number. Okay, if you put that in your calculator, you're going to get a long list of decimals that is never-ending and never shows any repeating pattern. But anyway, we'll round later. Don't worry about it. Let's go ahead and finish this off. So I'm going to bring this way up over here where I have more room and rewrite my problem. X minus 5 is equal to the positive or negative square root of 2. And again, I have two cases here. My first case is x minus 5 is equal to the positive square root of 2, which I'll rewrite here. X minus 5 is equal to the positive square root of 2. But I also have x minus 5 is equal to the negative square root of 2. Let's solve each problem separately. Let's start with the yellow one. So I'm going to add 5 to both sides, which leaves me with x is equal to square root of 2 plus 5, which we like to rewrite as x is equal to 5 plus the square root of 2. Now, that is the exact answer, okay? If I ask you for an exact answer, this is what I'm going to need to see, because if we take a decimal approximation of root 2, we're going to have to end up rounding it, because like I said, the decimal expansion is infinitely long and no repeating pattern. So that would be my exact answer. We'll look at the approximate answer in just a moment. Let's go ahead and solve the blue side now. So again, I'm going to add 5 to both sides, leaving me with x is equal to, in this case we have the negative square root of 2 plus 5, or as we like to rewrite it, 5 minus square root of 2. Again, that is the other exact answer. We can do a decimal approximation, but it's just that, it's an approximation. If I ask you for the exact answer, there's the exact answer. Now, let's find that decimal approximation just to make it a little more clear to us. So, I grab my calculator, conveniently across the room, okay? And I can punch in 5 plus the square root of 2. Notice I'm using the, I forget the name of it, the squiggly equal sign, we'll call it, okay? So, and then I just punch in my calculator, 5 plus the square root of 2, and it gives me 6.414213562. How about we round that to 6.41? And then over here, we do the same thing, but now we're doing x minus the square root of 2. I'm sorry, 5 minus the square root of 2. So 5 minus root 2. I get 3.5857866438. Let's go 3.59. Whoops, I should use I gotta remember the name of that. This symbol here, the squiggly equal sign, means approximately. Don't worry, I won't mark you down if you don't use it. So, our solutions, written in exact form on the top and approximate form on the bottom, are right here. And hence we have solved by completing the square again. Why did we go through all of this long process? Why didn't we just solve by factoring? We couldn't. And that is solving by completing the square.